Welcome to a new DataPeak Solutions Python project in the Week 2 track. We begin with three messy marketing files: ad spend, conversions, and customer records. They contain broken keys, bad dates, and inconsistent formats. Today, we'll clean the data, merge the files, and calculate real CAC and ROAS by channel. The complete code and all raw CSV files are free on GitHub. The link is in the description below. Three raw marketing exports land on your desk: ad spend, conversions, and customer records. Campaign IDs don't match across files, click timestamps are stored as plain text, currencies switch between dollars, euros, and pounds, and many customer IDs are missing. Nearly 1 in 4 rows has a data quality issue. In this episode, we'll clean the mess, standardize every dataset, and build the foundation for a real CAC and ROAS engine. Before cleaning a single value, we run diagnostics on all three datasets, checking every column's data type, missing values, and overall quality. The converted column is stored as an object, with 22% of rows empty. Click time shows 0 missing values, but it's saved as plain text instead of a proper date time. Customer ID is missing in about 4% of records. We know exactly what must be cleaned before we merge the datasets and begin analysis. 4 ad platforms mean 4 different date formats in one column. Meta uses /separated dates, Google exports full ISO timestamps, and TikTok stores day-month-year strings. None of them match. We solve this with pandas to underscore date time using errors equals coerce. Every valid date becomes one consistent timestamp, while invalid values are safely marked as missing instead of breaking the pipeline. Now, every downstream step works with clean, standardized dates. Before merging, we map how the three tables connect. Ad spend and conversions share a campaign ID, but that alone doesn't reach customer details. Conversions also include a customer ID that links to the customer records. These two keys connect all three datasets. Campaign ID joins spend to conversions, and customer ID joins conversions to customers. If either key is wrong, every CAC and ROAS calculation downstream becomes unreliable. Now we execute the joins. First, we perform a left merge on campaign ID to bring in the conversions. Next, we run another left merge on customer ID to attach the customer records. As soon as the merge finishes, the row count increases. That's expected, not a bug. One campaign can generate many conversions, so a single ad spend record naturally expands into multiple rows. We verify that increase before continuing to the next cleaning step. Duplicate clicks can quietly inflate every metric. Sometimes the same click ID is recorded 2 or 3 times by the tracking system. To fix this, we first sort every row by click time, then remove duplicates using click ID, keeping only the earliest valid record. Skipping the sort could preserve the wrong click and silently distort every downstream metric. After this step, more than 1,000 duplicate rows are removed, leaving a clean, reliable dataset that's ready for accurate reporting and analysis. Ad spend arrives in 3 currencies: dollars, euros, and pounds, all mixed into one text column with currency symbols attached. We strip those symbols, convert every value into a number, and apply a fixed exchange rate to standardize everything in US dollars. A dollar value stays the same, while euro and pound amounts are automatically converted. Now, every campaign uses one consistent currency, making spend comparisons and performance metrics accurate. With every table cleaned and joined, we build the reporting layer. Using Pandas pivot table, we summarize performance by platform and month, calculating ad spend in US dollars, total conversions, and revenue in one step. Instead of writing multiple filters and group operations, a single pivot underscore table call creates the complete reporting structure. The result is a clean summary that's ready for CAC and ROAS analysis. At this stage, the data is still scattered across thousands of individual rows. We use Group B with aggregation to total ad spend, conversions, and revenue for each platform. Instead of raw transactions, we now have clear business metrics. For example, Meta records more than $1,800 in ad spend, 7 conversions, and over $2,000 in revenue. Thousands of messy rows have become a clean summary ready for reporting and analysis. With clean grouped data ready, we calculate the two metrics that matter most. Customer acquisition cost, or CAC, is total spend divided by total conversions. Return on ad spend, or ROAS, is total revenue divided by total spend. We apply both formulas across every platform in seconds. Meta delivers the lowest customer acquisition cost, while Google is the most expensive. With just 2 calculations, the campaign performance becomes clear. Raw numbers in a table are easy to overlook, but a chart makes the story obvious. We create a ROAS bar chart with a single Seaborn bar plot call and save it using matplotlib. The results stand out immediately. Meta delivers the highest return on ad spend, Google follows closely behind, and TikTok remains well below break-even. In just one visualization, the best and worst performing channels become instantly clear. That completes the entire attribution pipeline from start to finish. We transformed 3 messy marketing exports with broken keys, inconsistent dates, duplicate records, and mixed currencies into one clean, business-ready dataset. Every script and raw CSV used in this project is free on GitHub. The link is in the description. If you enjoyed this series, subscribe to DataPeak Solutions for more real-world Python projects. Keep building.